We have a lot of attendees right now. Let them just join in. I think while the attendees join and we have more participants, let me just take 2 minutes here. Is it on the screen? Okay. All right. A very warm welcome to all the members here and also to Dr. Rajeevan, who will be chairing and hosting this session. So where we are and what we do is known to many of the members here. Many have been a part of the Future Earth community. So in short, I will not take much time. Just wanted to say that this program today is co-organized by our Future Earth South Asia office that you see a dot here. So we are a network of scientists, researchers, stakeholders, and we have 9 global hubs. The latest one being Africa, which just joined last month. And our strength lies in convening meetings with various stakeholders. And we also have a huge platform of global research programs, many of whom are also connected. So Anupama is going to send a link to a Future Earth website for our participants to know who we are, and also to connect to a research network. So where does the National Committee fit now? So along with the global hubs that you see in blue dots here, that's spaced all over the world, we also have national committees in the globe where the national priority is given in various dialogues. And our work is to link society, policy, and people together. And we make sure that knowledge advancement is what we want to achieve. And through knowledge advancement and various products, we have various programs set in all these global hubs. So I will not talk much about it, but with that, let me just stop as a very brief info. And I would like to also request Anupama to share the profiles of the speakers today and give an agenda. And with that, I also welcome Dr. Rajeevan, who will be chairing and moderating this whole session. So with that, welcome to all the attendees, the panelists, and all the members here. Thank you.
Thank you, Smriti. Just a quick overview of our speakers and our panelists today. They've already joined us. Of course, the chair and moderator of our session today is Dr. Rajeevan, who is the chair of the National Committee of Future Earth in India. And the first session of this webinar is going to be presentations by 3 speakers, each of whom represents the 3 different working groups of the IPCC report process. The first is Dr. R. Krishnan. He's the director of the Center for Climate Change Research at the Indian Institute of Tropical Meteorology in Pune, IITM Pune. He'll be presenting the insights from the first working group, which is the physical science spaces. The second speaker is Dr. Aditi Mukherji, who's also a part of the National Committee of Future Earth in India. She is a principal scientist at the International Water Management Institute at New Delhi, and her insights will be on behalf of the second working group, which looks into impacts, adaptation, vulnerability. And the final speaker for the day is Dr. Ulka Kelkar. She's the director of climate at the WRI India, the World Resources Institute in India, and she'll be presenting insights on behalf of the third working group, which looks into the mitigation of climate change. Following these three talks, we will have a very interesting panel, which is also moderated by Dr. Rajeevan. And our panelists here are Dr. Krishnan, who is a professor at the Center for Atmospheric Sciences at IIT Delhi. And then we have Dr. Chandni Singh, who is a senior research consultant at the Indian Institute for Human Settlements here in Bangalore. And then finally, we have Dr. Navruz Dubash, who is a professor at the Center for Policy Research in Delhi as well. So this is our lineup for today. And yeah, that is also the agenda. Dr. Rajeevan, over to you.
Thank you. Thank you, Smriti, and thank you, Anupama, for a nice introduction of this webinar. And good afternoon to all of you. And welcome to the featurette webinar on the recent IPCC assessment reports on climate change and in the Indian perspective. Thank you for your kind participation. And also special thanks to the speakers and panelists for sparing their time to participate in this important webinar. As all of you know that IPCC, Intergovernmental Panel on Climate Change, has released their 3 reports based on their 3 working groups. One is on working group 1 on physical science basis. Basically, it's the most up-to-date physical understanding of the climate system and climate change, bringing together the latest advances in climate science. The second group on impacts, adaptation, and vulnerability. Basically, it assesses the impacts of climate change, looking at ecosystems, biodiversity, and human communities at global and as well as regional levels. And last report, the big working group 3 is the mitigation of climate change, which is a very important subject. It provides an updated global assessment of climate change mitigation, progress, and pledges, and examines the source of global emissions. And so these 3 reports have come, but as all of you know that these reports provide you a kind of a global perspective on different aspects of climate change, for example, science of climate change and issues like impacts, adaptability, and mitigation efforts. So there's not much scope for elaborate analysis and discussion for different specific to particular country. So the present webinar is to discuss the salient aspects of these 3 reports on an Indian perspective. We have, as all of you know, that we have just witnessed a series of severe heat wave events now over India. And March and April temperatures are the warmest in the observational record, which we have almost 125 years, in spite of a La Nina event occurring over the Pacific Ocean. And it has really damaged the health system. It has killed many people, and also it has given a lot of pressure on, especially on energy sector. The question is what these IPCC reports mean for India. What are the serious climate threats faced by India? Are we doing good science of climate change in terms of modeling and simulations? If not, what are our priorities? What could be the impacts due to climate change being projected? Who are more vulnerable and also facing maximum risk? Is the concept of climate refugee is tourism in India? Is it really happening in India? And will it happen in near future? What are the options we have to face the consequences of climate change, for example, adaptation? What are our efforts in mitigating climate change? How we commit to reduce carbon emissions? Do we have the right kind of technology for adaptation as well as mitigation efforts? Finally, the most important question is what could be the economic implications for a country like India? How we are going to manage the funding mechanism? These are some of the questions at least I have in mind. I'm sure that the people who are attending this participants also will have their own questions in their mind. To answer all these questions and have a fruitful discussion, we have the best subject experts and also their IPCC lead authors with us today. So we should thank all of them. And there will be 3 presentations each on 3 working groups, WG1, Working Group 2, and Working Group 3 reports, followed by a panel discussions. Again, the best subject experts are participating as panelists, and I'm happy to see that 3 women scientists are participating in this webinar. So 50% participation from women scientists. Otherwise, there is to be always a complaint in the panel discussion that is to be called as a manalist. So at least that complaint will not be there for us now. So already the speakers as well as the panelists are introduced by Anupama. I will not go in detail. I will request Dr. Krishnan to give the first talk on Working Group 1 report. I request the speakers who may take about 20 minutes or so to complete their talk. At the end of 3 lectures, probably we'll give about 5 minutes, we'll spare about 5 minutes for any specific questions from participants. And if they can put the questions on chat and we can just follow it up and try to answer those questions. And this will be followed by a panel discussion that will be about an hour or so. So I want to thank South Asia, Future South Asia Office and Alimbawa as well as NC Media working with us for organizing this webinar. Thank you. So now Dr. Krishnan.
Yeah. Thank you, sir. Thank you. Yeah. Good afternoon to all of you. Thank you, Chair, and thank you all the Future Earth and all the panelists. Today I will be talking about the Working Group 1 perspective from the Indian perspective. What are the assessments, key assessments in the IPCC AR6? And basically, we had a meeting of all the Indian lead authors, including Professor Krishna Chutarao, who's a panelist today. So some time ago, a few months back, and this is basically a slide from his presentation. So we have in the Working Group 1, we have the summary for policymaker, the technical summary, and in the full report, the first chapter is framing, context, and methods. Chapter 2, 3, and 4 are from a global perspective about the changing climate, changing state of the climate system, human influence, in which Professor Krishna Chutarao is a lead author, basically about attribution. Chapter 4 on future global climate, in which Dr. Swapna from IITM and also Professor Bala from IASC were involved as lead authors. And chapter 5 to 9, they are basically process-based chapters. So I was in the water cycle chapter, water cycle changes, that is chapter number 8. And also one of my colleagues, Dr. Sabin, he was a chapter scientist in the chapter 8. And then we have a chapter 10, 11, and 12. They are having more regional focus. So one of the important points from the AR6 is that there is a very strong regional focus. That's an important chapter, linking the global and process to the regional scales. And there's also a very new innovation known as Atlas, interactive Atlas. That's also part of the regional chapter. And chapter 11 on extremes, Professor Subimal Ghosh was a lead author in this chapter. So this is just to give you a introduction about this structure. And there were some very clear attribution statements coming out about the human influence on the climate system. So this is basically what it says is the global mean temperature has increased by about 1.1 degree. And this warming is almost unprecedented in more than 2000 years. And this is the warmest multi-century period in the last 100,000 years. And based on the CMIP6 models, there were some 50 plus models that participated. They could clearly attribute that this warming trend that we are seeing since the post-80s in the global mean temperature can be explained only by if we include the human influence. Just the natural forcings like the volcanoes and the irradiance changes, they cannot, although they may explain some of the episodic coolings like the Pinatubo eruption or the El Chichon. But basically the long-term warming is coming because of the greenhouse gases primarily. And so this is one important message. And the other point is that the warming is driven by emissions from human activities, with greenhouse gases warming partly masked by aerosol cooling. So much of the global warming signal has been significant part of it has been masked by aerosols, mainly the anthropogenic aerosols, mainly the sulfur dioxide emission. And if we had only greenhouse gases, well-mixed greenhouse gases, the observed warming during 2010 to 2019, which is 1.1 degree. If we had only greenhouse gases, the warming would have been 1.5 degrees. And the total human influence is 1.1. And the other human drivers, like mainly aerosols, and they have contributed, they have offset it by about 0.4. So that is what we have to keep in mind. So there are these multiple drivers that are affecting the the global mean temperature, and also this has an impact on the monsoons, particularly the hydrological cycle. And one of the important consequences of this increasing temperature is that the hot extremes are increasing. This is for the observed period, the observed changes in the weather and climate extremes. This is the synthesis of observed change in hot extremes. This is shown in the form of hexagons on the superposed on the world map. And we have a hexagon over South Asia. So if we see 3 dots, that means it's a high confidence attribution about the human influence. And red color means basically it is increasing. So hot extremes over the past decade would have been extremely unlikely to occur without human influence on the climate system. And when we come to heavy precipitation, climate change is already affecting every inhabited region across the globe, with human influence contributing to many observed changes in weather and climate extremes. So when we look at heavy precipitation, observed heavy precipitation changes, over South Asia, the confidence is kind of low because of limited agreement across models. But we do see that there is an attribution. And in some places where there's kind of medium confidence, you can see 2 dots. And in certain areas, there is a kind of a low agreement in the type of change, for example, over Mediterranean and other places. So climate change is affecting extreme temperatures and also extreme precipitation, and as well as droughts. Basically, this refers to the agricultural or ecological drought, which is basically due to the increase in the evapotranspiration demand, atmospheric evaporative demand. And over South Asia, what we find is there is a kind of low agreement in the type of change. Of course, you do see some places, for example, in the Mediterranean, West Central Asia, and so on. There has been an increase in the agricultural drought in the past decades, which is attributable to the human influence. Over South Asia, the confidence is low. And for the future, we have different scenarios. In the AR5, it was based on the representative concentration pathways, what are known as the RCPs. In the AR6, the philosophies are what are known as the shared socio-economic pathways. So there are five scenarios that were used in the AR6 assessment: SSP1, SSP2, SSP3, SSP4, and SSP5. I think SSP4 was not there. And SSP1 is a kind of a very low emission scenario. It's a kind of a sustainable pathway. And the SSP5 is a high emission scenario. It's a kind of fossil fuel dependent pathway. So basically the SSPs are basically, it's a narrative based on the socio-economic narrative. And the SSP2 is kind of a middle of the road pathway, SSP, especially the SSP245. And I'll be showing some of the projections. Basically, it says that this is from the future. Global surface temperature will continue to increase at least until the mid-century. Under all emission scenarios considered, global warming of 1.5 and 2 degrees will be exceeded during the 21st century unless deep reductions in carbon dioxide and other greenhouse gas emissions occur in the coming decades. So they're very powerful messages. So we can see that in the next 20 years, we will be exceeding the 1.5 degree global warming. It's very, very clear. And the 2 degree warming we will be below the 2 degree only in the SSP 126 and 119, the low emission and very low emission and low emission scenarios. Even the SSP 245, the middle of the road, also we will cross the 2 degree limit as per the Paris Agreement. We will cross by the end of the 21st century. So this will be very likely range is around 2.7. And in the high emission scenarios, the warming is much, much higher. So, and with every increment of global warming, changes will get larger in regional mean temperature, precipitation, and soil moisture. So this is the observed, the left top panel is observed change, which is present, that is per 1 degree global warming, which is presently what we are seeing. And this is what is simulated by all the CMIP6 models at 1 degree global warming. So you can see much of the warming is strongest in the high latitudes and the polar regions, with also warming over the tropical areas, but more pronounced warming in the high latitudes and polar regions, and also in the mid latitudes. So, and this is the warming at 1.5 degree level global warming. If you can see again, this pattern becomes much more pronounced. And with 2 degree, even more, the pattern of warming is getting stronger. And likewise at 4 degrees, it's even stronger. And when we look at the precipitation changes with warming levels, we can see at at 1.5 degree global warming, we can see an increase in the precipitation over Africa, or Asia, or India. And primarily the precipitation increase is in the high latitudes, the polar regions, and the mid latitudes. Whereas the subtropical areas, for example, the Mediterranean region, and also Australia, southwestern Australia, Africa, and subtropical areas of South America and North America, there's a decrease in the precipitation. So it's basically the regions where the wet regions are getting better, and the dry regions, basically the subtropical areas, are projected to dry faster in the future. Similar pattern, you see an exaggerated pattern at 4 degree global warming. And also one of the consequences is that the extremes, with the increase in the temperature and the moisture, both the temperature and the precipitation extremes are projected to get larger, both in frequency and intensity, with every additional increment of global warming. What that means is a temperature extreme which was happening once in every 10 years in the pre-industrial period, is now presently it is happening at a frequency of 2.8 times, and at a 1.5 degree warming it will increase to 4.1 times, and with higher level of warming the frequency is going to increase further, as well as the intensity is going to get stronger. And also likewise the heavy precipitation over land areas, they are also going to get both the frequency and intensity of heavy precipitation one day event, which is going to increase in the future. And and also there's also a regional fact sheet that was a part of the AR6. Basically, the purpose of the regional fact sheet is that they are an outreach product that is fully traceable to the IPCC Working Group 1 6th Assessment Report. So it is basically a high-level key messages are included in the fact sheet, and also the fact sheet are focused on providing relevant regional climate information. This is one of the important components of the AR6, the regional fact sheet. And for the fact sheet, there are 11 regions around the globe, and Asia is one of them. And for the Asian region, there are about 10 sub-regions within Asia. South Asia is one of those regions. And various climate parameters are assessed, for example, temperature, precipitation changes, droughts, aridity, river flood runoff, and several other parameters, snow and ice, coastal, and so on. And so I'll quickly go through them. So this is a combined common fact sheet for the entire Asia, regional fact sheet for Asia. Some of the common regional messages for the Asian region are: the observed mean surface temperature increase has clearly emerged out of the range of internal variability compared to 1850 to 1900. Heat extremes have increased while cold extremes have decreased, and these trends will continue over the coming decades. It's a high confidence statement. Marine heat waves will continue to increase, high confidence statement. Also, average and heavy precipitation will increase over much of Asia, high to medium confidence. There are also other important messages in the fact sheet. Glaciers are declining and permafrost is thawing. Seasonal snow duration, glacial mass, and permafrost area will decline further by the mid-21st century, high confidence. Glacier runoff in the Asian high mountains will increase up to the mid-21st century, medium confidence, and subsequently runoff may decrease due to the loss of glacier storage. Relative sea level around Asia has increased faster than global average, with coastal area loss and shoreline retreat. Regional mean sea level will continue to rise, high confidence. And these are some of the projections of the precipitation and temperature and maximum temperature over 35 degrees for different warming levels, 1.5, 2, and 3 degrees. We can see that the pattern of warming increasing, particularly with increased global warming levels, warming all over the Asian region, and pronounced warming at the at the Asia in the middle of the continent, and also in the high latitude regions of Asia. And we see the winter precipitation, December, January, February, increase in the precipitation over the mid-latitude regions of the continents, regions of the Asian continent. And whereas over South Asia, the winter precipitation is slightly reduced over the South Asian region. For the June, July, August month, we do see an increase in the total precipitation over the South Asian region and also other parts of Asia. And the maximum temperature over 35 degrees. This is the number of days in a year. So the number of days per year with maximum temperature exceeding 35 degrees, you can see some substantially increasing as we go from 1.5 degree to 2 degree and to 4 degrees. So these are the projections based on the CMIP 6 models, in which IITM ESM is also system model also participated. And there's also an assessment of the global and regional monsoons in the AR6. In the AR5, we had basically the definition of the global monsoon, which is defined as the area where with local summer minus winter precipitation exceeding 2.5 millimeter per day. So the global monsoon region is shown by the black contour in this map. But in the AR6, we are focusing mainly on the regional monsoons. Where this is, we have a defined region. This is the South and Southeast Asian monsoon shown in the pink color. We have a East Asian monsoon. We have a Australia and Maritime Continent monsoon. And we have a West African monsoon, a North American and South American monsoons. These dotted areas which are shown over South Africa and Equatorial America, which were categorized as monsoons in AR5 because of the global monsoon definition. In the AR6, we don't call them as monsoons. They are associated with seasonal precipitation changes, but we do have an assessment of the seasonality in the precipitation. But basically, we have these 6 monsoon regions, which are shown in shading. Basically, the assessment is that the global land monsoon precipitation decreased from 1950s to the 1980s, partly due to anthropogenic aerosols, but has increased since then in response to the greenhouse gas forcing and large-scale multi-decadal variability. This is medium confidence. And during the 21st century, global land monsoon precipitation is projected to increase in response to greenhouse gas warming in all time horizons and scenarios, high confidence. In the long term, that is 2081 to 2100, global monsoon rainfall change will feature a robust north-south asymmetry characterized by a greater increase in the northern hemisphere than in the southern hemisphere, and an east-west asymmetry characterized by enhanced Asian African monsoon and a weakened North American monsoon. So basically, it is projected that the Asian monsoon and the African monsoons and also the South Asian monsoon is projected to intensify in the future. And there is also an assessment of the attribution of the precipitation and temperature changes based on the CMIP 5 models. These are the temperature and precipitation fingerprints of the greenhouse gas impact and the aerosol impact. So with respect to the greenhouse gas force fingerprint on the temperature, you can see much of the warming over the continents, pronounced warming in the polar and mid-latitudes, and similar fingerprint in the precipitation. You can see an increase in many of these areas, whereas the subtropical areas are drier. This is a typical fingerprint of the GHG forcing. Whereas when you look at the aerosols, basically, which have dominated in the northern hemispheric region from America, Europe, and Asia, this have led to a kind of cooling of the continents. And so studies have shown that when you cool one of the hemispheres relative to the other, the IPCC tends to shift southward. There are theoretical arguments for that. So the precipitation fingerprint is that you can see a decrease in the precipitation for many of these areas, including South Asia, and you can see increase of precipitation to the south of the equator. Yeah. So and also this is also supported the aerosols, mainly the sulfate emissions. They have led to a kind of what is known as a solar dimming, because they reduce the incoming solar radiation at the surface. And this was particularly very strong, the reduction in the solar radiation. This is from what is known as the global energy budget analysis based on station data in the northern hemisphere. And this decline in the solar radiation was very pronounced from the 60s to the 80s. And later on, due to improved regulation norms, particularly in US and Europe, and also with the increased warming, there has been a recovery of precipitation, particularly for the West African monsoon region. And of course, it is also accompanied by a decadal variability. And so this contrasting influence of the greenhouse gas and the aerosol forcing on the northern summer monsoon precipitation, the CMIC models are able to capture. Although the magnitude of the precipitation decline, which is also related to the decadal variability, the magnitude of that change is not, the models are not able to explain. That is, there's a shortcoming, but the sign of change the models are capturing. And so this is the assessment of changes in the monsoon, South and Southeast Asian monsoon, that is the pink region which I had shown. Basically, we had this is from the CMIP 6 models. We have 3 different data sets, the CRU, then we have the Aphrodite and one more data set, all showing a decreasing trend for the period 1951 to 2014. And this is the black whisker is based on the all forcing experiment. You do see a decrease. The median is showing a decrease in the decline in the precipitation. That is the trend. And when we take the aerosol only forcing experiment, you see it shows a very strong decrease, whereas the greenhouse gas only forcing, the GHG only experiment shows an increase. So the contrasting influence of the GHG and the anthropogenic aerosol on the precipitation decrease for South Asia is seen. And this is for the historical period. Of course, there is a kind of intraannual to decadal variability in the precipitation, which the models kind of underestimate. And coming to the future, we have shown for 3 different scenarios, SSP 126, 245, and 585. We have shown the projections for the near term, that is 2021 to 2040, 2041 to 2060, and 2081 to 2100 long term. We can see that in the future, particularly the midterm and the long term, very clear increase in the precipitation as the global warming continues. In the midterm, in the near term, for example, that is 2021 to 2040, you can see there is an uncertainty. This is mainly coming because of the internal variability and also due to the effect of natural forcings like volcanoes. That is a source of unpredictability. So the near term there's a lower confidence, but in the future, the mid and the long term, the South Asian monsoon is projected to increase. So these are the key messages for South Asia. The South Asian monsoon has weakened in the second half of the 20th century, high confidence. The dominant cause being the anthropogenic aerosols, especially since the mid 20th century. Heat waves and humid heat stress will be more intense and frequent during the 21st century. Both annual and summer monsoon precipitation will increase during the 21st century with enhanced intraannual variability. It is not just the mean will increase, also the intraannual variability will increase, medium confidence. Extreme precipitation has increased and will increase in the future. Droughts have increased, medium confidence. However, future changes have low confidence due to poor model performances. So in the past, the droughts over South Asia, there's only a medium confidence, and in the future, increase in drought is only, changes in droughts are only low confidence. This we have to keep in mind. And also the extremes, it's not only single extreme events, but also you can have compound extremes. In some situations, phenomena causing severe impacts go well beyond a single extreme event or a single climate variable. So it can include interaction of climatic conditions such as sea level rise and storm surges, precipitation in combination with strong winds, drought and heat wave, flood and sea level rise. Increasing observed trend and projected changes are seen for the compound extremes. In particular, for the Indian coast, will be under the combined threat of increasing cyclones plus extreme rainfall and storm surge and sea level rise. This is an assessment coming from chapter 11, extremes chapter. And as far as observed regional hazards in the high mountain regions, this is basically coming from the special report of ocean and cryosphere changes. This is I've shown over the Himalaya, Tibetan Plateau and other high mountain Asia. Basically the high mountain Asia, also known as the third pole, is an important Asia Water Tower. It supports a large population. It's a unique ecosystem, and it has a strong influence on the Asian weather and climate. And in this region, the water availability impact is going to be, it can be both increase and decrease, but it is a kind of high confidence assessment. The changes can be both, either you can have increase as well as decrease, and the assessment is a high confidence, 3 dots. Floods and landslides and avalanches are projected to increase. It's a kind of a low confidence statement. And basically, the glacier, snow, and permafrost decline has altered the frequency, magnitude, and location of most related natural hazards such as landslides, avalanches, flooding, ground subsidence, and wildfires. And with regard to the heat and cold, warming has occurred in the Himalayas, also other regions of the world. I'm not going into those regions. Such elevated dependent warming would lead to faster changes in the snow line, glacier equilibrium line altitude, and the snow and rain transition height, high confidence. And the freezing level height in mountain areas is projected to rise and will alter snow and ice conditions, high confidence. So this is basically the observed trends. This is based on the radio occultation data, GNSS, which has a very high vertical resolution. This is from 2002 to 2019 based on the satellite data, radio occultation data. You can see the pattern of warming entire the troposphere and cooling in the stratosphere. Typically what Professor Manabe and Weatherald had predicted, a typical signal of the global warming, GHG warming. So temperature response is coming out even in the tropospheric and stratospheric temperature profiles. And this is what is projected by the model for the period 2081 to 2100. SSP 126, you can see it's a low emission scenarios, warming of the troposphere and cooling in the stratosphere. And this pattern gets even more pronounced in the high emission scenarios. And with regard to the snow and glaciers, snow cover has reduced. This is for the high mountain Asia. Snow cover has reduced since the early 21st century, and glaciers have thinned, retreated, and lost mass since the 1970s, high confidence. Although the Karakoram glaciers, this is in the extreme northwest, have either slightly gained mass or are in an approximately balanced state. It's a medium confidence. So some glaciers in the Karakoram region, they have actually gained mass and slightly. And the snow-covered areas and snow volumes will decrease during the 21st centuries. Snowline elevations will rise, and this is high confidence. And glacier mass is likely to decline with greater mass loss in higher greenhouse gas emission scenarios. And this is going to be my final slide. Warm and wet. So basically precipitation decreased over the central eastern Hindu Kush Himalaya, but increased in the western Hindu Kush Himalaya. A general wetting pattern across the Tibetan Plateau and the Himalaya is projected, with increases in heavy precipitation in the 21st century. Rising temperature and precipitation can increase the occurrence of glacial lake outburst floods and landslides over moraine dam lakes, high confidence. This is a fact sheet from the Asian region, working group 1. Yeah, thank you very much for your kind attention. Yeah.
Thank you, Dr. Krishnan, for a nice presentation on Working Group 1 report and what are the relevance for India. And you discussed a few questions are there already, which we may take it up a little later. And of course, you are told the compound extremes are also increasing, but unfortunately, we don't have good research records regarding compound extremes, evidence in regarding compound extremes in India. We have not done such kind of studies in India. That's what my feeling.
Yeah, I agree. Yeah. I think that's an important topic. We have to develop the capability to address the compound extremes. That's an important issue. Yeah.
Okay, so we'll move on to the next presentation by Dr. Aditi Mukherji. She's the principal scientist at International Water Management Institute. She'll talk about the Working Group 2 report. Aditi?
Yeah. Thank you, Dr. Chair. Thank you, Dr. Rajeevan. I will largely talk about the Working Group 2 report, but also focus a bit more on land, water, and ecosystems related findings. And I'm hoping that my co-panelist Chandni will bring about the issues from Working Group 1 that I would surely miss, because ours was a 3,000 page report and we have covered a lot of aspects. But the main part of Working Group 2 is about, Working Group 1 is about the physical science, while the Working Group 2 is about how are people and ecosystems impacted, what determines vulnerability, and climate change is just only one determinant of that. And also how are people and ecosystems adapting. So I will try and cover all those three aspects as briefly as possible, and I will largely also draw from the water chapter, of which I was one of the coordinating lead authors. What the Working Group 2 says is that pretty much all of nature's crucial services are at risk in a warming world. So various chapters have looked at issues like pollination, coastal protection, tourism, food security, health, water, clean air, climate regulation. And just like Working Group 1, we also in the Working Group 2 had a series of thematic chapters that looked at various themes like water, food, health, cities. And then we had regional chapters which covered each of the continents. That was more or less the structure. Some of the future global climate risks that this report highlights are around heat stress. I think right now we are in a period of extreme heats all over India. Then the report also covered water scarcity, largely water chapter, where we are showing that at 2 degrees regions relying on snowmelt, and Dr. Krishnan just now talked about the Hindu Kush Himalayas, which is one of those climate hotspots. So relying on snowmelt could experience up to 20% decline in water availability. The report has a lot of content on food security, and that also is relevant for India as well as for flood risks. Now coming to the water cycle, what we are showing is our point of entry is where basically Working Group 1 leaves off, where Dr. Krishnan's chapter ends, is they are showing anthropogenic influence on the various components of the water cycle. So we take that, and from there our chapter basically works at how does those changes, and these are the changes that are we look at the changes in mean precipitation, heavy precipitation, cryosphere changes, stream flow, river flood, drought, groundwater, basically all the components of the water cycle, and how they have changed across the various regions. And this, the top part of it, is in line with the Working Group 1 finding, obviously. And then for the Working Group 2 water chapter, what we do is we look at in detail the impacts on the various sectors, because almost every sector uses water, agriculture being the largest consumptive user of water. So therefore, a lot of the impacts of changes in water cycle actually falls on agriculture. And overall, what we are finding, without going into a lot of detail, when it comes to the impacts, you can see that impacts are either negative or mixed. So almost all the sectoral impacts are negative. For some we have medium confidence, for some we have low confidence, because it's also the moment you kind of move from the physical variable to the use and the social variables, your attribution just becomes a more complicated because of a whole lot of other factors that get involved. But having said that, what emerges as a clear picture is that climate change has affected more or less majority of the sectors negatively, and the projections are also along similar lines. Just a few things. I think this is also a bit of repetition from what Dr. Krishnan has already shown. Heavy precipitation is mostly increasing. We are finding also dry spells are getting longer in some places and shorter in others. So the South Asia is here. Then one important finding, and this has been something that has been repeated in various rounds of this assessment, including in the SROC report, that was a special report on oceans and cryosphere. And that is that glaciers are melting and shrinking in all regions, including the Hindu Kush Himalayas, and that has implications for the rivers in India. All the major river systems originate in the Himalayas, and it also has implications on those mountain people who actually live in those live in high mountain regions. So one of the things that our chapter covers, but also the rest of the working group too covers, is quite a lot of focus on indigenous people and indigenous knowledge. And I'll briefly touch upon it in the course of this presentation. So overall, the glaciers have glaciated regions are high mountain glaciers are one of those climate hotspots that comes through all the reports. On the river flows, we find some river flows are decreasing, some are increasing. Within India, you can see both are happening, declining river flows towards the north and the western, while increases in the eastern ones. And also that these precipitation changes and associated uncertainties are projected to increase with global warming. I think this is also something that we have already heard. Here we are also saying the importance of not only going with the central estimates, but also looking at those 5 percentile and the 95 percentile, because often the models don't agree between these various scenarios. So the importance of looking at drier changes, wetter changes, as well as the central estimates. All this in the backdrop of something in the water sector, which is that approximately 4 billion people, that's almost more than half of humanity, already experiences severe water scarcity for at least 1 month per year due to climatic and non-climatic factors. So water stress, water crisis is already a reality, and what we are saying is that climate change is exacerbating various aspects of that water crisis. Just a minute. Then we also had some related numbers from the observed changes in floods. This is from WMO, which shows that between 1970 to 2019, 44% of all disasters and 31% of all economic losses were flood related. And then we also see in the observed data that human-induced climate change has increased the likelihood of heavy precipitation that then resulted in heavy floods. And and South Asia is also one of those regions apart from Europe, North America. So the chapter gives some of those examples in more detail. Similarly, when it comes to projections in flood, there is this estimate around estimated increase in population affected by river flooding is 120%. This is population for 2% and 400 for 4%. And the highest number of people affected by river flooding are projected in South Asia, Eastern and Southeastern Asia. And the part of it is also the population densities in these are higher. And obviously, vulnerability to flood is not only about the climate hazard, but is also about where your settlements are and what is the level of exposure and what is the current level of vulnerability of population who are exposed to such flood risks. Very briefly, our chapter, but then majority of the chapters in this report, and I think this is a novel aspect of the AR6, that there has been a lot of focus on indigenous people and indigenous knowledge. And here we are showing, and majority of these case studies are from one way or the other from the mountain and the cryosphere zones, because that's where a lot of the evidence around how melting of the cryosphere has affected these different what we call cultural uses of water. So these are not only water use for livelihoods, for productive water use, but water here is also like it has deep cultural meaning and is almost sometimes defines these communities. So we find that various many of these communities, and there are various examples, a lot of them are from the Himalayas, from the Tibetan plateau, but also from Nepal and from parts of Sikkim. So here we are showing that many of these communities have been affected due to increased snow glacier melting, and some of their cultural practices that defines them have been changed. What we also show is that indigenous people can adapt and they are adapting, but there are structural barriers and limits to adaptation. I'll come to that in a little while. And some of the examples of adaptation that can be disruptive for local cultures and traditions are alteration in herding routes. So we have many of these communities who are livestock herders. So that has been an issue around, or in the Himalayas, for example, in the northwestern part, you have irrigated systems that rely on these cryosphere melt, on these glacier melts, and once these glaciers retreat, those irrigation systems kind of get affected, and that often is the only source of livelihood. So that leads to migration, and also in some rare cases relocation, managed retreat, which also has a lot of negative consequences. Yeah, so I'll just stop there and then to the final part. So we basically work through each of those sectors. Sorry, I'm having a bit problem too. Yeah, okay. So we work through each of the sectors of the economy that has been affected. I do not go into detail in all of those. I just thought that I will focus on the indigenous people and indigenous knowledge, because that has been an overall a new focus in the AR6. What I really wanted to then also talk about is this particular working group 2 has done quite a lot of work trying to synthesize all the knowledge that there is around adaptation. And the thing with adaptation, especially around current adaptation, and I'm sure Chandni will talk a lot more about it, is that we have a huge number of case studies. These are not like modeling studies or anything. These are actual here and now kind of case studies, but they are often not done in a way that they are easily comparable. So what a group of IPCC scientists, but also scientists from beyond IPCC did was a huge meta review of all adaptation case studies published after the 5th assessment. And our chapter also drew on that larger meta review called GAMI, Global Adaptation Meta Review. And we wanted to see whether adaptation that is being done is actually helping in reducing climate risk. So we look at both adaptation in the current period as well as the future adaptation, which are more of modeling studies. Our first finding is around water is very central to adaptation, and we find that almost 60% of all adaptation is occurring in response to water-related hazards. These hazards are either droughts. You can see that these are some of the 16. In our chapter, we classified our adaptation typology into 16 broad categories, and we can see that the droughts and precipitation variability and extremes are two of the most important ones for which a lot of adaptation is happening, followed by heat related stress as well as general climate impacts. So which also means that a lot of people in the climate exposed occupations like agriculture are experiencing climate change through water. So water related adaptations are happening in every sector, but more so in agriculture, because agriculture is the largest consumptive water user. So that's no surprise. So we have actually looked at, I just forgot to say that this is a meta review. This is a database that comes from over 1800 articles, of which around 359 articles were the ones where we saw that the adaptation was actually linked to some kind of an outcome, because we have a lot of adaptation that does not necessarily conclude what the outcomes of those adaptation were. So we actually looked at only a subset of those studies that also looked at outcomes. So the most of the analysis is based on those studies. And then we divided those adaptation responses across various sectors: agriculture, water-induced disasters, human mobility, migration, urban, freshwater, energy, and industry, to see what is the evidence of adaptation happening in all these sectors. Remember, these are all peer-reviewed articles, and this is a lot of adaptation is happening without these kind of documentation. So this should not be taken as the only metric, but this is one of the metrics that we could easily analyze, because this was peer-reviewed literature, and that was the mandate given to us. So you can see that majority of those adaptations are happening in the agriculture sector. And the top 4 adaptation are around improved cultivars and agronomic practices, changes in cropping pattern and crop system, on-farm irrigation and water management, and water and soil moisture conservation, followed by a host of others such as collective action, migration, economic financial incentives, and there's a whole lot of adaptation that's happening. We are finding that adaptation is happening in almost all regions, but more so in Africa and Asia, where there is a high dependence on climate exposed occupations like agriculture. So a lot of these adaptation case studies are around adaptation in agriculture. And also another interesting fact is that a lot of the adaptation is on agriculture in global south, and while a lot of the water related adaptation in the global north is in the urban sector, which also kind of intuitively makes sense given the importance of these sectors in these different parts of the world. One of the things we often hear is that private sector should play a greater role in adaptation. One of our analysis shows that majority of these adaptations are autonomous and by individuals and households. And there is also a good role that the civil society is playing, as well as there is quite a lot of some of these adaptations have been actually also introduced by the government. But when it comes to private sector, by private sector, I mean profit-making private sector, the evidence that we find is that there has been less role of private sector in initiating these adaptation. By initiation, it could be funding adaptation or mostly funding, but also actually taking action on the ground. So we thought that was an interesting one, but it could be also an artifact of the kind of published peer review documents we assess. Everything has not been captured comprehensively. Then we also looked at what are the benefits of adaptation. We actually started trying to look whether adaptation reduces climate risk. And I think there are methodological challenges in actually relating climate risk reduction to adaptation directly, and that could be also the way the studies have been done. But overall, we are less confident that many of the adaptation are actually reducing climate risk. What we are very confident about is that adaptations have various benefits, and these benefits could be in terms of economic benefits, like improved livelihoods, improved crop production, or it could be benefits on the environmental front, like better water supply or better thermal comfort and all of those. But whether these adaptation actually then lead to risk reduction, and by that I mean reduction in hazard exposure and vulnerability, is something that's not very clear from the literature, and something I think from now till the 7th assessment, this is something we should focus as a social science community who works on adaptation. We found that in the global south, benefits of adaptation are economic and livelihoods related. For example, better crop varieties leading to better yields, etc. While in the global north, benefits of adaptation also includes better outcomes for the environment. So that was something. Okay, and this I thought was some of the more interesting part, which is there in pretty much entire report, where we are saying that not only is there a high level of vulnerability right now and people are adapting, but what's even important, given that we are on a trajectory of 1.5 degree pretty soon, we also are, the studies are showing that adaptation becomes less effective with more warming. Here, there is also very much a shortage of literature. Just as in current adaptation, we have literally thousands of case studies. The problem there with the case studies is that it's quite difficult to bring them together in a uniform format to do a proper assessment, which I think we still manage to do. The problem with the future adaptation, which are mostly modeling study, is that the number of studies themselves are quite limited. Part of it is perhaps research lacuna. We need to invest more in that kind of research, but part of it is also that many of these kind of adaptation, like migration, off-farm diversification, economic or financial incentives, all of these are not so easily, cannot be easily modeled into global climate models, which are required to do these kind of future adaptation. Having said that, we did find some 45 or so studies, if I remember correctly, and we looked at what would be the effectiveness of these particular adaptation practices, improved cultivars, cropping patterns, etc., at different degrees of global warming. And what we are finding is that the effectiveness of these to reduce projected risk is becomes lower at higher levels of global warming, and more importantly, there is a larger residual risk even after adaptation. So the main message remains that our adaptation space becomes more constrained after beyond a certain limit, and we are already seeing that with the heat stress. I mean, how do you kind of adapt to these high level of heat when physiologically a human body, or for that matter a crop, is not meant to be sustaining in those high levels? We also looked at the soft constraints to adaptation, and these were mostly financial constraint is the main constraint to adaptation, followed by governance, institutions, and policies. So I think this also came out very clearly in the Working Group 2 report about the need for climate finance and the need for that to reach those who need it the most. Very briefly, we also see that limits to adaptation have been reached with increasing warming, and some hotspots such as small islands and regions dependent on glaciers and snow will see those limits being reached pretty soon by 1.5. And finally, adaptation cannot prevent all losses and damages. Working Group 2 also had a lot of findings around losses and damages, and these damages will continue to occur despite adaptation, and losses and damages are unequally distributed and are not comprehensively addressed by current financial, governance, and institutional arrangements. And this is the concluding sentence of the summary for policymakers, which is really appeal for urgent action. The scientific evidence is unequivocal. Climate change is a threat to human well-being and the health of the planet. Any further delay in concerted global action will miss the brief, rapidly closing window to secure a livable future. Thank you.
Thank you, Aditi, for a wonderful talk on Working Group 2 report and what is the relevance, especially for water sector. And there's a serious water stress due to climate change, and also you have discussed regarding a different option for adaptation in water sector. And of course, there are also concerns that water adaptation becomes less effective with more and more warming. So a lot of good lessons we learned from this report. So thank you very much for sharing these important results. I think we'll have a little more discussion during our panel discussion. Now I will move on to Dr. Ulka Kelkar. Ulka is the director at Climate at World Resources Institute, India. She will talk on the salient aspects of the Working Group 3. Ulka?
Thank you very much, Dr. Rajeevan. Let me just say I'm not an IPCC AR6 author. So thank you very much to Dr. Rajeevan and to Future Earth for inviting me to share this Indian perspective. This week, we have seen the worlds of Working Group 1, Working Group 2, and Working Group 3 intersect very dramatically. There's been a lot of concern around the world about the heat wave in South Asia. From impacts and adaptation perspective, we've heard from the government that wheat production might be affected, and internationally exports might be affected at a time when people are already concerned about reduced wheat available from Russia and Ukraine. And then on the mitigation side, there's been concern that even some states that had said that they will not require new coal capacity to be built, even they are thinking of rolling back on that decision as a result of the power shortages due to the heat wave and the increased demand for air conditioning. So while we have presentations separately on the science, the impacts, and the mitigation, certainly in the real world, all three of them intersect. Let me start. About half of my presentation will be about some key findings from the AR6, the 6th Assessment Report, Working Group 3, and then the other half of my presentation will have some, I'll take the liberty of presenting some non-IPCC analysis specifically for India. So we see over here that greenhouse gas emissions have continued to rise. We can see over here that, that the good news is that the rate of growth of these emissions globally has come down. In the decade of the 2000s, it was 2% per year. And in the decade of the 2010s, it is 1.3% per year. So that is something to be at least take in mind, that greenhouse gas emission reduction is possible I think the IPCC report talks about 20 odd countries that have had a sustained reduction in their greenhouse gas emissions, some of them even taking into account consumption-based emissions, that is the imports of the commodities that they consumed, but which are manufactured elsewhere. In terms of the modeled pathways though, one of the findings of the IPCC report is that even if countries achieve what they're saying that they will do in the United Nations Framework Convention on Climate Change, the gap between the global greenhouse gas emissions and where we need to be in order to limit warming to 1.5 degrees Celsius is still very significant. It will be 19 to 26 gigatons of CO2 in 2030. Instead, the pathways that are modeled and which are reviewed in this IPCC report, they show that if we really want to model a scenario in which emissions are such that global warming stays within 1.5 degrees Celsius with little overshoot, then greenhouse gas emissions globally need to start declining almost immediately. These models have 5-year kind of time slices. So basically they say that almost immediately we need to start reducing emissions, and it needs to fall by about half in 10 years. So that's really the scale of the challenge, and the fact that current international policies and the current international architecture of negotiations is perhaps not adequate to the scale of the challenge. But I'm sure Navroz will be speaking more about this in the panel discussion. In terms of fossil fuel infrastructure that has already been built, the report estimates that that the emissions over the lifetime of existing and planned fossil fuel infrastructure would be about 850 billion tons of CO2. However, if we really want to stay within 1.5 degrees Celsius warming globally, then the carbon budget that is available is 510 gigatons of CO2, 510 billion tons of CO2. So what they're pointing out is that the existing pipeline of fossil fuel infrastructure already exceeds the amount of CO2 that we're allowed to emit globally in order to stay within 1.5 warming. So clearly what it means is compromises somewhere. Either we breach that budget, or we basically need technologies like carbon dioxide removal technologies, and I'll come to that at the end. The good news for me, I mean, why I'm optimistic about all of this, is that we find that over the last decade, the prices of the market costs of clean energy technologies have fallen dramatically. The cost of solar photovoltaic has been slashed by 85%, same for lithium-ion batteries for electric vehicles, and the cost of onshore wind by 55%. The gray bands that you see over here are the cost of fossil fuels. So already you see many of these renewable energy technologies becoming competitive with fossil fuels. And interestingly, this fall in prices, in market costs, is much more than what any experts predicted. This chart is something that is updated usually every year, and the International Energy Agency has a projection usually in its World Energy Outlook about how it sees the renewable energy market developing. And year after year, we find that what happens in reality far outstrips the projection. So basically, consistently, the experts in this case have projected that the renewable energy sector would hardly grow or even contract. And we see this very steeply declining black curve that shows how the sector has grown. However, even with all of this good news, the reality is that the adoption of renewable energy and electric vehicle technology still needs to increase several fold. You can see over here that the share of electricity produced in 2020 from solar photovoltaics was only 3% of the total. And this is for the world as a whole. For offshore wind, it was less than 1%. And this is something that's particularly becoming important for India, because solar PV requires land at such a scale, and with something which might at a high scale interact with the use of that land for farming, for grazing, for biodiversity. And so we really need to look at many other alternative technologies, even as we scale up the existing mature technologies. So let me just end with this part with a couple of key findings from the IPCC report about lifestyle and consumption. I think for the first time, there was a very interesting analysis done by income group. And we find something that I'm sure all of us have suspected, and all of us are in that top decile. households with incomes in that top decile are responsible for 36 to 45% of total greenhouse gas emissions. And this is, of course, a global number. Whereas those who are in the bottom 50% account for only 13 to 15% of global greenhouse gas emissions. So while there is injustice in terms of the fact that historically the cumulative greenhouse gas emissions have come from the industrialized countries, there is also a definite inconsistency or a mismatch in the way lifestyle emissions these days are contributing to greenhouse gas emissions. And there lies an entry point for intervention. The important thing to note from the IPCC report is that achieving universal access to modern energy for the world's poorest will not significantly impact global emissions. So even as India tries to meet the unmet energy needs of its population, that is not something that we need to be concerned about. What we do need to focus on is shifting consumption patterns, particularly among the wealthiest in the world, which can cut greenhouse gas emissions by a projected 40 to 70% by 2050 compared to the reference scenario. One major finding, and I'll illustrate this with some examples from India, is that climate finance for mitigation must be 3 to 6 times higher by 2030 to limit warming. So the issue is not where the opportunities are for emission reduction. The issue is also not whether those opportunities for emission reduction are economical. Many times they pay for themselves. But the problem is that the upfront capital costs that they require is often something that is out of the financial ability of the countries or the income groups who are in a position to undertake that mitigation. So what we need is, urgently need, is international climate finance. Both public and private finance options are being considered, but at an aggregate, 3 to 6 times is the estimate of the IPCC in terms of the scaling up of climate finance that's required. Finally, the sort of pessimistic finding from the IPCC report is that even after doing all of this, all of these technologies, finance, everything, it may still have become almost impossible for us to limit global temperature rise to 1.5 degrees Celsius. It's almost like it's a goal that is slipping out of reach. And we would require carbon removal technologies, either natural ones, like, of course, planting trees, mangroves, grasslands, other forms of nature, but also technological approaches like literally scrubbing carbon dioxide out of the air and other forms of capture from power plants and industrial plants. So with this, let me come to a few slides from an Indian perspective. As I said, I'm just taking the liberty of sharing some analysis. This is an open access model. You're all welcome to go and have a look at it and change the assumptions and so on. I just wanted to illustrate a few points for India. First of all, when we look at the projected growth of emissions from India over the period 2020 to 2050, we see that yellow band, which is emissions from the electricity sector, hardly expanding. So even as India adopts all of this renewable energy, what we find is that we'll be able to meet our growing electricity needs without actually increasing our emissions. So electricity is sort of, you could almost argue, is the simpler part of the decarbonization challenge, even though on the ground, there are many things that are required to happen between this theoretical analysis and the actual realization of this potential. The red one, which is transport, you can see is growing from a relatively small base. And I'll tell you a little bit about this. We often suspect that this is coming from cars or from planes and so on, but that's not really the case. The gray band is industry. And when I say industry over here, we are talking about industrial emissions, which are not arising from electricity use. So electricity use is in the yellow one. In the gray industry, we're basically talking about fossil fuel use, chemical processes, and so on. So that's what we call the harder to abate sectors, which cannot be often solved by electrification and by clean electricity use. But let's go a little deeper and see where the transport emissions are projected to come from. And you can see that much more than personal transport, these are likely to come, the whole black band is from the trucks on the road. So here we find that there are often solutions hiding in plain sight. What we need to make sure is that we shift as much of this freight traffic from road to railways as much as possible. in addition to looking at other technological solutions. On the industry sector, if you look at the major emitting industries, we see iron and steel as one of the biggest emitters. And here too, we begin to see signs of where the solutions might be. As much as possible, we can of industrial processes, we should electrify and use renewable energy to provide that electricity. But then there are certain high temperature processes that cannot be electrified easily. So then we come to the issue of green hydrogen, which you would all have been hearing a lot in the news these days. And that's something that needs to become more affordable, perhaps over this decade, as the government's hydrogen mission tries to aggregate demand from industry and create the necessary supply chains. We might find the cost of hydrogen falling over the decade of the 2030s and 2040s and becoming a way to decarbonize the harder to abate sectors. But more importantly, what we need to think about in industry is really going beyond energy efficiency improvements and looking at material efficiency. So circular economy, which means that anything like reusing scrap metal, repurposing concrete waste, even reusing wastewater, recycling of battery minerals, all of these will be required going forward, not just for the emissions reduction, but also because we have relatively scarce domestic reserves of some of these minerals. And in adopting these circular economy approaches, we can also create new kinds of jobs. We will also need many other options. I won't go into the details of this, but I just want to identify, I want to highlight a few options. If you were to arrange the various types of mitigation options required, say for India to reach its net zero 2070 target, you will find on the left-hand side, these negative cost options. That is, in some sense, they pay for themselves because they lead to fuel savings. And on the right-hand side, you find the more expensive options, which require international finance and technology. But if we look at these negative cost options, we see things like shifting from road to rail in terms of the mode of transport, energy efficiency in buildings, in transport, and then also, as I said, material efficiency, longevity, and reuse. So really, there are timely intervention points at which we can change the way we build our buildings. And here again, I would end by saying that there is a kind of intersection between working group 1, 2, and 3. Because if we were to use green building materials, green building design, we would not only reduce the emissions required in our cities, but we might also help to improve thermal comfort and provide a better quality of living in our urban areas. I'll just end with a last slide, which is saying that all of the analysis that we've presented has been from a climate change lens. But if we look at the actions that are required for India to reach its net zero 2070 target and to have this kind of bending of the emissions curve, we find that there will also be positive effects as a result of the same actions on air pollution, on health, and on water. These calculations show that millions of premature deaths can be avoided as a result of reduced emissions of SOx, NOx, and particulate matter. And we find that as the power sector shifts from coal to renewable energy, a lot of the fresh water that is required for cooling of these coal power plants can be saved. Trillions of liters of water saved in an increasingly water scarce, water stress scenario as we go forward. So let me close my presentation and thank you once again for this opportunity and look forward to any questions.
Thank you, Ulka, for your nice presentation on Working Group 3 and the salient points with respect to carbon emissions. And now we will have a panel discussion. And before that, we have a couple of questions. Probably I will just read out, and I think some of the questions are already answered by Dr. Krishnan, but still 1 or 2 questions. Like for example, a question on soil moisture. As global warming is going to affect soil moisture, what can be the implication of this for Indian agriculture? How do we handle the consequence of this? Another related question is, our current regional global models are able to quantify the direct impact, especially for example, cooling of large-scale land use changes in a specific region like India. So Dr. Krishnan, you would like to answer this question?
Yeah,
regarding the land surface processes, soil moisture, reduction in soil moisture.
Yes. Yeah, I can answer that. Can you hear me? Can you hear
Yeah,
me?
we can hear you. We can hear you.
Yeah. For example, the projections for the Indian region, the precipitation is projected to increase in the AR6. So this means the soil moisture will basically increase. So if soil moisture is projected to increase, even though temperatures may increase, there will be more evaporation, more soil moisture. So heat waves due to the soil, generally if there was a drying of soil, less precipitation and drying, then that can lead to more heat waves because of the increase of sensible heat. Like you can expect that in Mediterranean region. But over the Indian region, I don't think we will have that problem of a heat wave coming because of soil moisture. Maybe it may be very infrequent because the projections are indicating an increase in the precipitation. Soil will become wetter, so there will be more evaporation, not the sensible heat. So I don't think its impact on the heat wave is going to be a big concern. So heat wave may be due, of course, if there is a big drought or something due to El Nino or some other remote influence, we are having a precipitation decrease, then soil moisture drain. There at that time, maybe you can have heat wave type of condition.
Okay, thank you. So I think I am not finding any other question in the chat box. So I think we will then thank all the three speakers for their wonderful lectures, and we will move on to the panel discussion. In the panel discussion, we have, as introduced in the beginning, Professor Krishnan Rao is professor at Center for Atmospheric Science in IIT Delhi. Dr. Chandni Singh, senior research consultant from the Indian Institute of Human Settlements, and Dr. Navroz Dubois, he's the professor at Center for Policy Research in India. So welcome three panelists. And I think I will start with Dr. Krishnan Rao. I think I request all the panelists to spend about 15 minutes time to give your further discussion as well as further insights to the problem, questions which we discussed. And then we can summarize it probably at the end of the panel discussion. So for Dr. Krishnan Rao, Dr. Krishna has spoken about the IPCC Working Group 1 report salient aspects. For example, what could be the implications for India? We are happy to see that monsoon is going to be robust. It is not going to affect the monsoon rainfall, but the extremes are going to change. Now my question is, our modeling strategies really good in India, especially I'm talking about climate change scenarios? Do we have adequate people to do good research? And we find an important conclusion that from AR5, AR4, AR6 climate change simulation, especially for monsoon season, is improved a lot. And if you really see, the models are doing extremely well when compared to AR5, AR4 or monsoon, Indian monsoon, or Asian monsoon, South Asian monsoon. That's a good beginning, and but there are dry bias and so and so. So we have improved our models so that improved model means we have more confidence in our future climate change scenarios. The main question for policymakers is how good these projections are, because they are going to take a very solid decision, and this involves a lot of money, economics, based on these climate change simulations. 10 years back, they used to say that we have still time. There are a lot of uncertainties in this climate change simulation. We can wait and see how the things are going. But now this is not the time to wait and see, isn't it? This is a too high time for us. So my question is, our model results, simulations are quite good enough for the policymakers to take a good decision? Or do we need little more efforts, not little more efforts to improve our models? And the ultimate aim should be to reduce, of course, there could be a lot of uncertainty. Even short-range forecast, we know there's a lot of uncertainty. So climate change simulation definitely will have uncertainty. The question is whether we can do something more research to improve that uncertainty, reduce the uncertainty. So are we in the right track in India? At least I'm talking about Indian research, climate research. There are a lot of groups are working. I know IAC, IIT Delhi also doing a lot of work, and IITM, there are so many other institutes, IAC Bangalore, so many institutes are working. So that's my one question which I I'd like you to answer. So other then you can also discuss any other aspects related to science of climate change. Thank you, Professor Krishna.
Thank you, Dr. Rajeevan. You've raised a very important question. And to my mind, I think what we need to answer first is what do we want to know from the models, right? So for all these years, we've asked the models certain questions. Most global simulations, especially for the IPCC effort, they've been sort of more aimed at looking at what's the global changes in climate that we expect, what kinds of rainfall or temperature change, or more recent AR6, well, what's the change in extreme events. So that's one sort of set of questions. They've been sort of more aimed at getting at the mitigation question, really. To my mind, models have not really been put to use to answer questions of, okay, so we already have climate change upon us. It's happening, it's being felt, we are seeing the impacts of it. What do we do about adapting to it? Do we have that question being asked of climate models? And to my mind, I think at least in India, the scientific community needs to pay attention to the adaptation question, because what is it that we're going to adapt to? I mean, because everything that's in the IPCC reports, they speak of general trends, increases in extreme events, in whether it be rainfall or heat waves or any of that. But when we come down to the local, regional scales, all of us understand as scientists that, the fact that you may have a water body or an irrigated piece of land will change what happens to a heat wave, what happens to extreme temperatures. Similarly, orography and things like that will drastically change the kind of extreme event that we'll experience. So I think while we know the general trends of the changes that we might expect, in order for us to make a more fine-grained set of decisions that affect citizens living in different parts of our country, we need to have a little more effort put into where the people are, what do we think drives changes within those regions, small geographic regions, not just in terms of the rainfall or the heat wave that's going to appear, but also in terms of modeling the impacts, the downstream impacts, what it does to crops. So we have to look at how we integrate our physical climate models with these impact models. And to a large extent, a lot of new literature coming out tells us that it's not just that, meteorologically an extreme event will necessarily produce the largest impact. There are cases where the weather variables may not look so extreme, but they end up producing an outsized impact. That's because there are factors other than the ones that we model that actually impact how something ends up affecting, whether it's a crop or something else. So I think we need to go that extra mile now. We have the capabilities within the country to be able to model. Of course, now we have to push it. We have to push that next frontier where we take these modeling capabilities and look at where those impacts are going to be. Yes, these will likely be very wrong in our first attempts. These are probably going to be highly uncertain, but we are not going to learn unless we start making those attempts. So I think when we recognize that our models, for a long time, people have said, okay, we'll run our GCMs, we'll hand off the rainfall and the temperature and humidity, and somebody else will go off and figure out how much river runoff there is. But I don't think we can do that anymore. We have to be hand in glove with the hydrologists and the crop modelers and everybody in order to integrate how these systems actually work. And we need to be able to understand at the scales that they work. So I think this is where I would like for Indian science to pay more attention, because it is happening in other parts of the world. People are looking at large ensembles where, because of the noise of weather, certain model runs will end up with high impacts, or others will end up with very low impacts. So we need to understand what are these changes that we actually look at that are robust to the climate signal. But that doesn't mean we ignore the other part, because one of the findings in the IPCC Working Group 1 has been that we look at the next short term, next 20 years. It is not the climate change signal that we are going to experience. Well, not the main thing. Most of what we will have to experience is driven by internal variability, the decadal scale variability. So we need to be able to understand not just the robust climate signal change that we will have to deal with, but also the variability, the decadal and multi-decadal variability that is going to be on top of the climate change signal. So we may end up with, like this year, for example, when we've had heat waves in March and April, and this may not happen again 5 years down the line, and we may tend to relax. But these are parts of variability that occur naturally, and we cannot ignore that part either. So it's our job is now actually more compound, in that our ability to model the climate is not just modeling climate change, but to be able to capture the variability, the phases of variability. Because as you rightly said, it's very difficult to make policy decisions for something 50 years down the line. But if we are able to tell something about what part of the variability cycle we are in, that we may be able to tell you 1, 2, maybe 4, 5 years down the line, what kinds of impacts might be coming down with our climate variability and change, that's actually actionable information for decision makers and for adaptation decisions. And we also need to make sure that we are keeping in mind the end result of all of this modeling work that we do. And I think if our effort is more as a sort of an early warning system, a disaster management system, I think we're going to miss the bus. I think we need to look at this as okay, what if this happens? What is the worst that can happen? Rather than look at, okay, a deterministic, this is what will happen, and therefore, go shelter from a cyclone or whatever. But I think we need to look at the kinds of situations that are unfolding, look at models in a way that we are not looking at it for these firm yes/no answers, but look at it as what is most probable down the line, which you will have to, which will have a large impact on society. Because there are certain outcomes which we'll probably be able to deal with, but there will be more that we don't know. And one of the examples that, some of my recent work, it's a work that's been submitted for review. So, but just to give you a flavor, we look at what heat waves could be in, 1.5 or 2 degrees C climate. So in that work, what we are finding is that we're now finding, as IMD would define a heat wave, we find that in the month of July, there will be heat waves in large parts of India, right? So, this is unprecedented. And you can imagine with the humidities that exist in July, the temperature heat wave is going to be completely different. So I think what we need to look at is these kinds of situations that are, these are not predictions, but these are possible outcomes that we need to plan for. And to my mind, those are the kinds of things that we need to look and feed into the adaptation conversation, where scientists really should be participating. And I think we would be doing a disservice both to science and to the country if we didn't come in with insights that could be of help. And that's my personal interest is in doing this. Of course, within India, while all this that I've mentioned is possible to do, we still have a shortage of people that are capable of doing this. We really need to increase the numbers of people that go in and are interested. There are a lot of young people who are interested in climate change and climate science. We want to catch them younger, bring them in. Unfortunately, in India, we don't have an undergraduate curriculum that teaches people atmospheric science and climate science. And then, you kind of by accident end up in this field. Hopefully we can change that by bringing people in at a younger age so that they're not looking at this as an afterthought after a BSc or a BA in something else. So that's, I think we need some work to be done in getting people into the field, as well as changing the sort of focus of our questions. So I'll leave it there and hand it back to you. Dr. Rajeevan, you're muted, I think.
Sorry, I'm muted. Yeah. So happy to see that our models are improving. And one of these constraints which we have is these models, but what you use now are little of a coarser resolution. So we need to really go for a little higher resolution, for which we need a much faster computer. Much faster computer means more money, more funding to science and S&D ministries, and so on and so forth. So it goes on. And another aspect which you discuss is the want of people, want of right people. And it's a good point. And also we need to really have a good coordination among the research communities within India. I mean to say climate modeling groups within India. I think we need to get together instead of doing piece by piece, somewhere else, one institute, then another institute, they do some other work. So we can think of getting together the modeling community and doing. And recruiting young people is also very, very important. So fortunately, we are getting nowadays a lot of institutions, universities are producing good people, young people. And there was a serious issue of recruitment. For example, a few years back, as a student who is coming with MSc in climate science. For example, some universities, they teach in MSc in climate science. For example, IIC, I think they have MTech program in climate science. But they are not allowed to enter into our ministry because our recruitment rule says that only physics, maths, chemistry people can join. So it was very hard for me to change it. Now I'm happy to see that climate science people can join Ministry of Science and do climate modeling. So we need to do this kind of small things so that our research community also gain importance and they contribute a lot. So thank you, Professor Krishna, for your nice insight. So we'll move on to the next panelist, Dr. Chandni Singh. So Dr. Aditi, she has discussed about the adaptation issues, especially related to water sector. And she made a lot of good points that maybe in the future, if warming is still further increasing, adaptation may not be a good choice, may not be possible, for example. But already people are doing a lot of adaptation in the water sector. So it's about 60%. She was mentioning about number. So it is encouraging. So now question is whether if the same issues are there for other sector. It's so water sector, I think probably it is well researched, but we don't know about, for example, agriculture, for example, health sector, for example, energy sector, for example. So do we have good results to show that adaptation, what are the adaptation issues in these sectors? In addition to water, actually, Aditi has spoken very well. So you have any other insights? You can give more insights to other sectors also. Aditi, Chandani Singh.
Sure, Dr. Rajeevan, thank you so much. And yeah, I mean, Aditi covered a lot from the water chapter and also quite a expanse on what Working Group 2 report is saying on adaptation. I'll just add a few more things and then perhaps also pick up a bit on what Professor Achyutarao said about teaching and just capacity building in the country, especially around adaptation and risks. I think I'd like to say something on that. So first of all, of course, while we've been talking a lot about India being on the front line of climate change, a lot of impacts we're already seeing, and then we know that we're going to see heightened risks. We also know this whole idea of compounding and cascading risks, which I think is critical. But we tend to sort of push under the carpet this idea of pre-existing vulnerability. And I think Working Group 2 in a great way spoke about this, how we have a lot of evidence to say that not only different countries, but also within India, you have so much differential vulnerability. So when a heat wave or when a flood is occurring, it's not going to affect everyone equally. And I think some of our projected risks, the models that project risk into the future give us these large numbers of X number of people affected, or 60% of wheat yields are going to go down. But how does that affect different people differently is something that our models aren't able to capture very well. So that's one knowledge gap that I see. And I am not a modeler by any stretch of imagination, but if there are ways to do that better, I think that's one gap that we should think about addressing. How do we bring this pre-existing vulnerability and then the climate change impact drivers together and layer that to talk about future risk? The second thing is around adaptation. So we did a big assessment. I was a lead author in the Asia chapter, actually, which was a regional chapter. And we did this large assessment of different adaptation options that various countries are undertaking. Of course, India also has a good set of sectoral adaptation plans. We've got, Aditi spoke about water, but then there's also an agriculture, in cities, health sector. I think we have a decent set of adaptation options we are undertaking, at least a set of options that are feasible or possible. And we do a full feasibility assessment of these different options, adaptation strategies that we can really implement. The problem that we see is, first of all, a lot of that is right now in the planning stage. So we have plans to do X, Y, Z. We have a heat action plan or a flood resilience plan, but that is not really moving into implementation. And when it's moving from plan to implementation, the evidence of its effectiveness is really weak. We either don't have any studies on effectiveness, or the effectiveness is only in terms of cost benefit. This is the amount of money we put in, this is the damage we reduced. But effectiveness in terms of ecosystem services, in terms of human well-being, these are things that we have just not captured, I think, we just don't have the evidence really. So we couldn't do a full effectiveness study for other sectors. Water sector at least had some metrics to capture. The other thing that we show actually when we've done this feasibility assessment of different adaptation options is that there are combinations of options that you can put together to reduce risk. So an example from cities where you can have infrastructural solutions for dealing with floods, but then also nature-based solutions, also some behavioral change about how people are growing things, or there are a range of behavioral options also in the adaptation side. We often talk of behavioral change for mitigation, but the first time we had enough evidence, I think, in this report to talk about how do you change behaviors and perceptions of risk to incentivize adaptation behavior. So we talk about these combinations of solutions rather than one adaptation action here and there. And I think we, at least for sea level rise and coastal flooding, we have some nice adaptation pathways that are qualitative pathways that are developed in the report. So I think I can imagine Working Group 1 and Working Group 2 scientists sitting together and actually talking about the modeled pathways that we see on risk and impact, or the climate impact drivers, and then these possible adaptation pathways that we have in Working Group 2 and bring them together, which at this point, we don't do that kind of work, I think, in India, which is quite a gap. Finally, I think some of the interesting stuff that Working Group 2 really focused on was around, we know that there are a range of adaptation strategies. We also know that some of these strategies have co-benefits or synergies with mitigation, so greenhouse gas emission reduction. We know that they also have synergies with some of our sustainable development goals. So there are these, what we call triple wins, right? You can reduce risk, mitigate your GHGs, as well as meet some of the sustainable development goals. But while these options exist, how do you really enable them happening? And that's where the implementation or the real action around adaptation takes place. And we've, of course, I mean, there are 6 enablers that we talk about in Working Group 2. Things like you need to have the technical capacity, the finance to do it. And I think these things we already know about. But what I want to highlight is, one is institutional capacity and behavioral change. So we talk about, and often we tend to reduce institutional capacity as what, like people who are making decisions and planning and managing some of these choices around risk reduction. How can they really make choices to adapt? What the problem I feel here is that is some of the barriers that we highlight in the report and in the Asia chapter especially, is that the capacity to make decisions around risk management under these conditions of deep uncertainty into the future. So not only short term, but medium and long term. We are talking of projections up to 2100. How do you make plans for 2100 when, you know, our governance systems are in a certain way, they're functioning at much shorter timescales? So that, I think that kind of social science and really policy research around implementing adaptation is something that really needs a lot of funding, I think, in India. It's we tend to always talk about climate change either in mitigation terms or the climate science, and somehow the implementation side of it really falls through. And in my opinion, at least especially from this time's Working Group 1 report, there is no doubt we have enough science to say with a lot of high certainty that India is really going to experience significant risks. So there are some other barriers. More knowledge does not mean better action. You know, there are other barriers. Once we've got the data, how does that data move into policy making, decision making? So it's really that capacity building around decision making under deep uncertainty. Those are the terms that we use in Working Group 2. And deep uncertainty is this idea of where there are lots of known knowns and then unknown unknowns, where we just don't know as we go right up into the future what's going to happen. And then finally, of course, we know also, again, Working Group 2 very clearly speaks about adaptation limits. So we know very clearly now we are already hitting some soft limits. And then into the future, we are going to hit hard limits beyond which either human systems or natural systems completely collapse. So knowing that while we are Working Group 2 and we focus on adaptation, it just strengthens the argument around mitigation. And so that's my other point. While we need to make the link with Working Group 1, we also then need to make the link with Working Group 3, which I think just because of the way the working groups are structured, we aren't able to do that. But at least at a country level within India, this kind of a webinar is a start of that, where you start making those links between the working groups and then actually have these interdisciplinary teams of scientists come together and say, all right, this is what the adaptation side is saying, this is what the mitigation side is saying, how do we think about climate resilient development, the term that at least Working Group 2 uses. I think I'll stop there. One last small point on pedagogy. I think already, I think you all have mentioned it a bit. One of the things, at least this heat wave has been making me think about, is the people who need to be trained on climate change is not only people interested in climate change, but it's actually different disciplines who are not thinking about climate change at all. So in our MBBS courses, undergrad medical training, there should be courses on heat waves and how do you deal with that, showing the projections of climate risk. Or if you look at Working Group 2, we've got clear projections of vector-borne diseases, how that's going to spread, both like incidence and the spread of diseases. We're going to see dengue and malaria up to, the foothills of the Himalayas, which don't typically see these diseases. So how is our medical profession dealing with that kind of risk? How are we training our staff there? So that's just one example of a group of people who aren't thinking about climate change. I think similarly, there are other sectors that need a lot of capacity building and just exposure to ideas on all these risks that we are highlighting in the IPCC reports. All right, I'll stop there. Thank you so much.
Thank you, Chandni, for a wonderful insight on adaptation issues. And I have two small questions. One is do we have adequate studies of understanding the impacts of climate change on various sectors? And this adaptation comes later. So first we should know what could be the impacts and different sectors, that also on regional basis. And for example, agriculture, I remember there are a lot of studies, especially from ICAR people and all, but sectors in health, for example, health sector. I'll tell you my experience, getting data from health sector is too difficult. First of all, they don't keep a good record. For example, people dying from heat waves. I'm not sure whether health authorities have a clear-cut record saying that on this day, some people died, and out of this, so many people died because of the heat wave stress. We don't have. So unless you have this kind of data, we cannot really do kind of impact studies, then adaptation issues and all will come later. That's number one. So do we really need to isolate that kind of research in India? And that's number one. Number two is, I discussed about the concept of climate refugees, because you are working in human settlements. So I want to ask you, is it really a reality, or is really something happening anywhere? May not be in India, but the climate refugee concept is a real concept, or only in just papers?
I hope it's not in papers as well. I don't like that term at all, but let me come to the first point you make. But there is a lot of conversation on climate migration and this idea of refugees. I can speak about that. I think the first one on impacts, actually, there are studies, there are sectoral studies, as you rightly said, on agriculture. Particular crops have a lot of emphasis as expected. Wheat, rice have a lot of studies, and going up to different temperature levels, that kind of modeling, I think we have a very good, actually a good set of studies. Some of the other Asian countries, especially Central Asia, we just couldn't find good, robust studies. So on impacts on agriculture and particular crops, we have good studies. Also in the forest sector, we have good studies. IISc also does so much good work on climate change and forests. Health, as you're saying, so the two ones that I think are under-researched, one is urban areas, mainly because there's so many different risks coming together in cities. So you've got simultaneous cycles of drought and floods happening. So there's compounding, cascading risks coming together in cities. And also, I think Mumbai, Calcutta, Chennai, they get a lot of focus on, like the urban research tends to focus on these large mega cities, but the smaller cities and rural or towns that are transitioning into cities, there is absolutely no information on the kinds of impacts those places are seeing. And those are the places we can intervene in. They're not yet built enough. So I would even think of commissioning really small studies on some emerging towns, not even big cities, and vulnerability impact studies there, and then maybe testing some adaptation strategies in those to see if they work or not. This is just an idea. But the health thing, we have also been exploring this quite a bit and trying to get good data on mortality and morbidity because of the heat wave. Government agencies don't have it. Hospitals, it's difficult to get the data. So we don't even have mortality numbers, let alone the other side of, labor productivity loss, smaller things, heat stress, heat strokes. So it's a big data gap to start off. And one more thing I'd highlight is, even in our Asia chapter, we've mentioned this. Some of these impacts could fall under what we call loss and damage because of climate change. The economic loss and damage, which is tangible, infrastructure damage because of flooding, loss of lives, that, although it's still patchy, we still have some data. If you look at non-economic loss and damage, it just doesn't exist. So an example of that would be how water stress is leading to more conflict, or how water stress is leading to more drudgery, women or particular people having to travel more. there are very few studies, and they're very, like, we don't know how to project that into the future. They're still very focused on current levels of risk. So non-economic loss and damage, we tried to do a study on non-economic loss and damage because of drought in cities. And apart from newspaper articles, we couldn't find robust peer-reviewed literature around this. So it's a big gap, I think. And again, Indian cities, rural areas both see a lot of cycles of too much water, too little water. What are the loss and damages because of that? That's unclear. Small one on the refugees and migration point. I've been doing quite a bit of research on this. From all the primary data that I have collected around movement because people move on the move, especially rural to urban, climate change is a driver. It is not the sole driver. It is not even the most important driver of people moving. People in India have always moved, and mainly because of economic reasons. The only thing is that climate change and environmental change, so things like natural resource degradation, groundwater loss or reduction, that is exacerbating it. It's an additional driver, but it's not the main thing. The more interesting story around climate migration in my mind is actually once people move, what happens to them? And are they now being exposed to new climate risks? So from rural Karnataka, the studies I have done, drought-prone rural Karnataka, people are then moving to localized flooding in Bangalore and living in informal settlements and being exposed to new risks. People who weren't equipped with dealing with floods are now seeing floods. So there is a changing risk profile for migrants as they move from rural to urban areas. And we don't have good strategies to support our migrants. Some states like Kerala, I think, have better social safety nets for migrants, but this paranoia around millions of climate refugees moving from small island states to perhaps Europe and USA and all of that, I think that is unfounded currently. There are modeling studies, but they're critiqued a lot in the migration literature. So.
Thank you very much, Chandni Singh, for a nice illustration on climate refugees also. So we'll move on to the last discussion. This is regarding the working group 3. That's the most important, probably in my understanding, is the most important. It's mitigation of climate change, in which I'm not an expert. I think Ulka has given a good talk. And now we have Dr. Navroz Dubois. He's the professor at Center for Policy Research. So Navroz, you can give more insights, because I'm not a good expert to ask you a few questions and all. So only my question is, India is doing right things for the mitigation of climate change as expected as a responsible country? And what could be the implications on, for example, economy of India? And second thing is, in your group, did you discuss, there is a lot of concept of geoengineering to control climate. You know that, for example, so cutting down solar energy and putting aerosols in the stratosphere, that kind of, did you discuss in your group such kind of geoengineering aspects also? These are the only two questions I think with my expertise I can ask you. So, but you are a subject expert, I think you should discuss much more. So Navroz, it is your turn. Thank you very much.
Thank you, Dr. Rajeevan, and thank you for inviting me. I've been listening to all the speakers with great interest. I learn a lot from these cross working group conversations. So I want to just add a few things to what Ulka Kelkar said about working group 3. I will focus more on the part that I have worked on, but I'll try and cover the broader part. The part I worked on was I was a coordinating lead author for the chapter on national and subnational policies and institutions, which is a mouthful. But before I do that, a few sort of broader comments about the bigger message. One of the things that Ulka also touched on was this question about 1.5 degrees and 2 degrees, and whether 1.5 degrees is within reach, which is kind of the political narrative. Now, obviously, it's very hard to actually say something about this in a way that is both that is analytically robust, because the way these models work, you can of course make them fit all sorts of shapes. of the curve. The question is whether or not we can reach 1.5 is more of a political question. Is the shape of that curve still realistic? Can social and political systems get us to very steeply decreasing emissions? And what the modeling said actually was not just that we need negative emissions by mid-century, but that we also need not just net zero globally by the middle of the century or thereabouts, but also we need to have quite steep reductions on the order of about almost 50% by 2030 from 2019 baseline, or about a third reduction if you're to reach 2 degrees. So it's not just net zero, but it's also short-term, quite steep reductions is what the report said. And whether or not that is feasible is a political judgment. The report doesn't get into it, but it basically says that the carefully calibrated language is that this is out of reach unless there are immediate changes and immediate reductions. I think to all intents and purposes, we're not seeing the signs of it. But the implication, I think, of this is also, and this ties back to kind of the 1.5 report, is not necessarily to think about 1.5 as some kind of cliff face. It's basically to say that the impacts, when you look at working group 2, are substantially already showing up. The future impacts are likely to be severe. So we shouldn't be thinking about whether it's 1.5 or bust. We just have to do the best we possibly can, because 1.5 is better than 1.6, is better than 1.7, is better than 1.8. But let's not think in terms of some kind of, discontinuous cliff face at 1.5. 1.5 is a politically constructed number in some ways, as was 2 degrees before it. So that is kind of the messaging, which says, okay, let's not just obsess over that number. Let's try and move as fast as we can. And here's what we can tell you about the trajectories and what different temperature targets imply for global average trajectories. So that's the first kind of broad point I want to make. The second point is another overarching point that I thought is worth bringing up, which I'm sure because of time reasons Ulka wasn't able to cover, which is that the language the report suggested for how to think about climate change is a little bit different from the previous assessment report, in that they introduced this language of shifting development pathways. And this is not meant to be, and it's actually kind of a family resemblance to the climate resilient development pathways language of working group 2. Now, this is not meant to be a language that is only pertaining to developing countries. It is meant to be a language that says climate change is substantially influenced, or mitigation options are substantially influenced by larger mainstream economic decisions as well. It's not just about renewable energy, it's also about urbanization. It's also about how you create your jobs. It's also about how you allocate your budgets across different things. And so the implications of this development pathways language are at least threefold. One, that the challenge of development and poverty alleviation and poverty eradication is also tied to climate change, not in a simple relationship, but the impacts of climate change will make many of the objectives of development also harder. So you can't be thinking about development in a way that is divorced from the impacts of climate change. That's the first thing. The second thing is, let's not be shy about saying that some of the changes that are required are going to be disruptive and big changes. If you're talking about moving from a coal-based economy to renewable-based economy, that is disruptive of coal communities, coal regions. New renewables may not come up where the old coal is, and so on and so forth. And it's not just coal and renewables. In many ways, it could be disruptive. Whole industries are being changed. The internal combustion engine will eventually have to give way to electric vehicles. There's a whole supply chain associated with that that will also get disrupted. So these disruptions are real. Let's not sugarcoat the fact that this will happen, but the disruptions are not a reason not to do it, because overall the costs of mitigation are very likely to be outweighed by the benefits of mitigation, and particularly so when you include in the various co-benefits. So we do have to seize these disruptions in some way, but they should not fall on the poorest people, which is why we have to very intentionally think about anticipating and planning and the state of our term these days that people are using as shorthand is a just transition. So that is something that is worth thinking about and planning for in advance. So that's the second implication. So one, sustainable development also requires thinking about resilience and impacts. Second is that there will be disruptions, but we need to try and anticipate them and plan for them. And the third is that when you think about development pathways, it opens up many more doors and openings to mitigation. As I said, it's not just about your energy system, but it's also about your energy demand system and how you use energy, as well as various choices. So this language of mainstreaming, that we have to think about how you internalize climate decision making on the both adaptation and mitigation sides is very important. So it doesn't make sense, for example, if you give a little bit of a subsidy here to renewable energy, but then you build a whole bunch of infrastructure that, for example, locks you into road-based freight. And I think Ulka made this point about the benefits of rail versus road-based freight. So you can't make your decisions about freight investment in a way that is innocent of its climate impact. And that is particularly true for countries like India, where the infrastructure is substantially yet to be built. And so for a country like India, it's not about reducing emissions. I don't think, for at a low level, we didn't contribute that much to historical emissions. It's not about reducing emissions, but the choice is how do we squeeze most development out of the least carbon? That is, how do we avoid locking into high trajectories of future emissions? And that's a good thing to do partly for climate reasons, but it also comes with a lot of co-benefits. And it also increases the chance that a country like India will be on the cutting edge of technology, because as the world moves to a low carbon future, cutting edge technology is increasingly going to be low carbon technology. So we have this sort of triple incentive, in a sense, to be thinking about how to avoid locking into a high carbon future and how to seek out a low carbon development trajectory. But the key word being, it's still a development trajectory, right? It's not foregoing development. So that's the second big point about development packages. The rest of the points will be a bit shorter. One of the things the report does for the first time is it has a chapter on the demand side. So normally the IPCC Working Group 3 report has so-called sectoral chapters. There's one on energy, land use, transport, buildings, and so on. There's one that cuts across that is on the demand side. And basically it says that for various reasons, thinking about how you use energy in particular can actually give mitigation gains at lower cost. Part of the argument is the lock-in argument that I just gave, but it can use you can bring about reductions at much lower cost, often on shorter timescales, because demand-side technologies tend to have shorter gestation periods, and then innovation cycle tends to be faster as well. So there's a lot of thinking one can do on the demand side. We shouldn't just get obsessed about the energy supply side. Turning to some themes from the chapter that I was co-leading, one of the points is that if we are taking this approach to policy making that says we are thinking about development at the same time as we are thinking about mitigation, we are thinking about justice and just transition at the same time as we think about mitigation, we are thinking about innovation and new technology systems. And I use the word very carefully, technology systems, not just technologies, right? Because you have to have a whole system to move from the internal combustion engine to the EV, for example. If we're looking at all those things, then single instrument policies are not going to work. So just putting in place a carbon tax, or putting in place a fuel tax for that matter, or putting in place a cap and trade program, which is what AR5 talked about a lot, is not going to work. Instead, you need packages of policies that complement each other. So if you want to bring about these transitions, if you want to think about a just transition, for example, you might have a subsidy for a particular fuel type that is cleaner. You might have disincentives for dirtier fuels. You might have to have worker retraining programs. You might have to have regional development programs. So you have to have a whole package of things that work together. Now, that's much more complex policy making than just picking from a list of 6 or 10 policy instruments. You have to think about how they interact with each other and complement each other. But that is the shape of policymaking in the future. There's a related point to that, which I think picks up something Dr. Chandni Singh was saying, which is that because this is so much more complicated, you also need to think much more carefully about whether you have the capacity in government in particular, but also outside government and at all levels of government to do this kind of complex policy making. So, in my own writing, some of which, is reflected in the chapter, we call it building a climate ready state, because the governance challenges of climate change are so much more complicated because you have to look at interactions across different sectors. We've touched on several of them here. You're looking at agriculture, you're looking at water, you're looking at forests, you're looking at the interaction across all of these. Similarly, on the mitigation side, you have to think about sort of a strategic story about innovation and how you're going to set up your economy. Ulka talked about hard to abate industries. That is at least a 20, 30-year planning horizon for how you're going to shift heavy industry away from dependence on fossil fuel as a primary source of energy. So you've got to think in a long-term way, and you've got to think with political sophistication, because when you're making these transitions, you're taking whole industries and you're confining them to the dustbin, and you're leading new industries to emerge. So you're having a big churn in your political economy. Obviously, those who are going to be losers will try and slow down the pace of change. If you're going to make that transition happen in ways that people who are potential economic losers don't throw sand in the wheels, you have to find a way to bring both sides together and figure out a transition path. And countries like South Africa, for example, have really specialized in doing this. They've created a presidential commission that anticipates what these transitions might be, tries to think about how to do it, and so on. So policy packages require a climate-ready state, and it also requires financing the upfront costs, which is something, again, that Ulka mentioned. I'll just pick up a further number from what she said. There's an interesting graph in the report that talks about the multiple of money that is needed beyond what we have seen in 2019 by 2030. Globally, that number is about 4 to 6 times more. For South Asia, that number is 7 to 14 times more. So that is the scale of the additional investment need that we are talking about here. Dr. Rajeevan, you asked me to talk about a couple of other things which are, to be honest, a little bit outside my comfort zone. The report does talk about geoengineering, but it doesn't talk in very prescriptive terms. It talks about the range of options and where are the options that we have reasonable knowledge about, and where are the options that we don't have a great deal of knowledge about. So it's more of a kind of laying out of the options approach that it takes. One of the challenging issues is when you do these various model runs, how much you assume that future technologies to uptake emissions are going to be available. I think this was something that the report authors the chapter authors who worked on that were aware of in this chapter, because there was a fair bit of criticism in AR5. And I think they've tried to accommodate that in how they've done the curves this time around. But I was not privy to the inner workings of those models. But if anybody's interested, I can always take questions and look it up and get back to people. Thank you.
Yeah, thank you very much for your nice insights to the mitigation aspects, especially for South Asia. And we know that it is very costly affair. And my question is India is doing the right things now? I think you may have a difficulty to answer.
Well, I can't answer that using the backdrop of the IPCC, because the IPCC doesn't ask or try to answer that question. Okay. But obviously, all of us on this panel are engaged in or trying to observe policy discussions. And so I'll give you my personal view on this. My personal view is that that the key thing India should be doing is thinking about avoiding locking into high carbon futures on a sector by sector basis, thinking about where the key transitions are happening in key sectors. we're urbanizing rapidly. How do we make sure we don't lock into high carbon cities and so on and so forth? I think that there's a lot of scope for co-benefits in areas like, particularly in urban areas, we can design our cities to be both low carbon and more livable. We are doing some things in some areas. Obviously, we have this very large renewable energy capacity target. But frankly, I think that we should be looking not just at capacity, we need to be looking at the whole electricity system. And I think that one of the reasons we are not looking in as quite a system level way as we could be doing, and the cost of not doing that is we're not actually looking hard enough for the synergies that of development and climate, including the potential job creating opportunities. We need to be looking harder for those. And one of the reasons we're not doing that is this point about a climate ready state. This is not an issue that you can hand off to a Ministry of Environment and say, can you please lead on this? It is just too, with due respect to all the colleagues in the Ministry of Environment, and in candid moments, I think they would actually agree. This is something that has to happen at a level which can bring multiple ministries together. And many of these issues are also being dealt with at the state level. So there needs to be much closer coordination between center and state. So we are doing a lot of things. And this is not just true of India. There's huge scope for improvement. I think one could make that statement about most countries in the world, all countries, I would hazard to say, and India is among those countries. Of course, we could do more. And I think the report actually gives some interesting hints of where we could be thinking harder, being more creative, building the state capacity and so on.
Thank you. Thank you very much. So with this, the panel discussion is completed. And my question is, do you have any questions from people for the panelists? I am not finding anything.
So there are no questions in the Q&A box or chat, but there is a participant who has their hand raised. I can allow them to talk if you.
Yeah, I think Raju. Is it someone like Raju?
Yes, sir.
Yeah, you can ask the last question. Raju. Yes.
Oh, hello, sir. Hello.
Yes, we can hear you.
Sorry, it was by mistake. I raised the hand. It is for Krishnan's talk. Yeah, but it was already answered by Professor Krishnan.
Okay, thank you. Thank you. So with this, I think we have completed all our good discussions, and we should thank all three speakers as well as three panelists for sparing their time and giving us a wonderful insights to the very complex issues of climate change. And so I think Anupama and her team, I think we'll prepare some kind of a brief note about what we discussed, and we'll be happy to share with you, and we'll use it for further correspondence with future and as well as government authorities in India. And so thank you very much for all of you for sparing your time. Thank you very much. Wish you all the best. Take care. Thank you.
Thank you.
Thank you.
Thank you, Dr. Rajeevan. I'd like to thank
you.
all the speakers and panelists on behalf of Future Earth South Asia and the Vecha Center for Climate Change as well. As Dr. Rajeevan just mentioned, we are preparing, notes on the discussion that took place today's session, and we will share them with you. And the recording will also be available on the Vecha Center YouTube page. So if you want to disseminate that amongst your circles or share it with anyone, please feel free to do that. And just one more note about what we are doing here in Future Earth South Asia is, I think Smriti had also mentioned this in the beginning. Our focus really here is on a regional program that we've set up based on inputs from our governing council. We're focusing on 4 main themes, including risks to coastal communities in South Asia, then building sustainable communities in both urban as well as rural contexts. The third is tackling food insecurity and malnutrition in South Asia. And finally, the fourth is one that looks at all the health risks associated with the 3 themes above. So what we're doing is setting up a network of experts in the whole South Asia region to really try and put together some sort of a concerted effort to try and work on these specific issues. And we hope to have a summit soon at the end of this year here at IISc. And we will hopefully see all of you there. So thank you so much again for attending today's session.
Thank you.
Yes.
Thank you.